In this lecture, we'll talk about how we can get an absolute age on a rock. With absolute age dating, we use properties of atoms in the rock to determine the actual age of a rock versus their relative age. First, let's take a quick review of an isotope. An isotope is an atom that has a different number of neutrons. Same number of protons, but different number of neutrons, therefore different mass. With radioactive decay, a neutron in the isotope will break down into a proton and an electron. The electron leaves the atom as a beta particle. The nucleus loses a neutron but gains a proton. Some isotopes will give off alpha particles, which is 2 protons and 2 neutrons. In this example, we have lead. It gives off a beta particle, and that turns into bismuth, so it's a completely different element. A half-life is the time it takes for half of the atoms in the isotope to decay. A couple of examples. The half-life of carbon-14 is 5,730 years. Carbon-14 is an isotope of carbon-12. So if you have 100% of carbon-14, after 5,730 years, half of the atoms are going to decay, so you're left with 50%. And that's going to turn into nitrogen-14. Then after another 5,730 years, another half will decay. So now you're left with 1/4 of the remaining carbon-14, or 25%. Another common one we use is uranium-238. We use this one because it has a half-life of 4.5 billion years. Remember, the Earth is 4.6 billion years. So we can use this to date the age of the Earth. Here are a couple of visualizations. At time 0, we have 100% of the parent atoms. At 1 half-life, half of the parent atoms are left. So we had started out with 20, now we have 10. So we have 10 parent and 10 daughter. At the second half-life, another 50% decays. So now if we had 10, we're going to now have 5 parent atoms left. At the third half-life, we have another 50% decay. So 5 divided by 2 is 25. So every time, it's 50% from the previous half-life. This is a different way of showing the half-lives. At the first half-life, or 0 half-lives, we have 100%, a full circle, 1/1. At the first half-life, 50% decay, so it's 1/2, 1/2 of a pi. At the second half-life, if you take half of a half, you get 1/4, so you're left with 1/4. At the third half-life, you have 1/8, fourth half-life, you get 1/6. So if you look, the denominator each time is multiplied by 2. So geologists use this radioactive decay and half-lives as a clock to measure how old a rock is. All we have to do is look at the percentage of parent atoms versus the percentage of daughter atoms, and we can figure out the age of the rock if we know the half-life. Let's use this graph to answer the next couple of questions. The first question is, how old is the rock after 2 half-lives have passed? So we start here. This is the first half-life and the second half-life. So the rock is 50 years old. The next question. After 2 half-lives, how much of the material has decayed and how much is left? We started out with 100%. We now have 25%. So 75% is decayed, 25% is left. Last question. If the rock is 100 years old, how many half-lives passed? If we start here, this would be 1 half-life, 2 half-lives, 3 half-lives, 4 half-lives. So the answer is 4 half-lives. Take a moment to copy down the answers. Carbon-14 is used for dating fossils, bones, and wood up to 500,000 years old. Once the organism dies, it starts to decay into nitrogen-14. Why would we use carbon to date organic material? The answer is because organic material is made out of carbon. Rocks that can be radiometrically dated are igneous and some metamorphic rocks. Sedimentary rocks, however, cannot be absolute dated. Why is this? Here's a hint. Think about what sedimentary rocks are made out of. Sedimentary rocks are made out of sediments or broken pieces of rocks. So if you take a whole bunch of broken pieces of rocks, put them together to make one big rock, you're going to get a different age every time you date it. You're going to get the age of the sediment, not of the rock itself. You're going to have to do some absolute dating math problems. To do these, there are 2 steps. Step 1 is to find how many half-lives passed. Step 2 is to calculate the age of the rock by multiplying the number of half-lives passed by the half-life of the parent atom. This is a number that will always be given. Now there's a couple ways we can do this. To find out how many half-lives passed, you can first find the percent. So take however many grams left over divided by the amount of grams originally present. Or you can divide the original amount of grams by 2 continuously until you get the number of grams left that you're looking for. Let's do a couple sample problems. Okay, the first example, the half-life of uranium-238 is 4.5 billion years. If a rock originally has 40 grams of uranium-238 and now only has 5 grams of uranium-238, how many half-lives passed? Then, how old is the rock? So the first step is how many half-lives passed. Remember, there are 2 different ways we can do this. The first way, you can take 5 grams divided by 40 grams. So what we have left divided by the original, that's going to give you 12.5%. 12.5% equates to 3 half-lives. How do I know that 12.5% means 3 half-lives? Well, if we start out with 100 and divide it by 2, we get 50. If we take 50 and divide it by 2, we get 25. 25 divided by 2, we get 12.5. So this was 1, 2, 3, so 3 half-lives. Another way we could do it, if we take 1 half-life, if we take 40 grams divided by 2, we get 20. We need 5 grams, so take 20 divided by 2, we get 10. Again, we need 5 grams, so we take 10 and divide it by 2, we get 5. So I divided it 1, 2, 3. So I divided it 3 times, therefore 3 half-lives. The second part of the question is how old is the rock? So we take 3 half-lives times 4.5 billion years. The first part of the question we determined there was 3 half-lives and 4.5 billion years was given to us. You do that multiplication, we would get 13.5 billion years. This is a different way that I could ask the question. If a rock has 6.25% of carbon-14, how many half-lives passed? So instead of giving you grams, I gave you percent. You can pause this video and try to work it out yourself. At the first half-life, if you take 100, because we start out with 100% of the material, and divide it by 2, we end up with 50. We need to get to 6.25. So we take 50 divided by 2, we get 25. 25 divided by 2, we get 12.5. 12.5 divided by 2, we get 6.25. That's the number we're looking for, so we stop. Now we add up how many times we divided. 1, 2, 3, 4. So the answer is 4 half-lives. Now the next part of the question states that if the half-life of carbon-14 is 5,730 years, how old is it? To find this, we take the number of half-lives that pass, which is 4 half-lives, and we multiply it by the number that was given to us, 5,730 years. So 4 times 5,730 years gives us 22,920 years.